You are watching the 5.9 Factoring Completely Day 2 Notes video. All right, so here's the deal. Nothing is new here. We are going to do pretty much everything that we have done in the 5.8 video. You just might see some things that are slightly different. So we're just going to follow along, factoring completely. Example number 1. Okay, so it says to factor in check. Maybe we'll do that on a couple of them just so we can see what a check would look like. Example number 1, remember, the first thing that we always hunt for is the GCF. So if I look at 3, 3, and 18, we can see that 3 is the greatest common factor. And out of all of my x's, I have x squared that I can pull out. All right, so what's left over? Well, that would be x squared plus 1x, or just x, and then minus 6. All right, so 3x squared is left over, and we're going to try to factor x squared plus 1x minus 6. We can head over to use the box if we would like, or we could try to factor in our brains. Some of you are still set on using the box, which is totally okay with me. Let's see. So we have x. Oops, where am I writing this? In the wrong spot. Okay, x squared plus x, or plus 1x, and then minus 6. So what times what will give me x squared? That's x times x. And then what two numbers will get me to multiply to negative 6 but add to positive 1? I feel like that's a positive 3 and a negative 2, because there's my negative 2x, there's my plus 3x. I'm going to have a southern accent. I don't know why. Okay, so we have x minus 2, x plus 3. So here is my final answer. And remember, we can always jump to our calculator and we can graph the original and the new to make sure that the two are the same, and that's how we know that our answer is correct. And that's how we would check. Also, I should point out, we could always undo these problems in order to check. Like I could double distribute and then multiply the 3x squared back in, just like reverse, to end up with my original. That's another way of checking. I think that takes a little bit longer. I think the technology check is probably one of the nicer methods. Okay, example number 2, check for a GCF. Do 45 and 5 have a GCF? Yep, 5. So 45 divided by 5 is 9. 5 divided by 5 is 9. So we're just pulling that 5 out. Then we want to see, can this binomial be factored? And by gosh, by golly, sure can. Because it's the difference of two squares. Oh my gosh, this is so easy. I don't even need to use my box here. Because the square root of 9 is 3. So 3 and 3. The square root of x squared is x. So x and x. One of them's plus, one of them's minus. Bam. That was so fun. All right, moving to example number 3. Number 3, we're going to look for a GCF. Wow, there's tons of GCFs going on here. What is it, 10? I think 10 is my GCF here. So we're left with 2x squared minus 17x plus 21. Yes, it was 10. All right, let's factor this trinomial. I'm going to use my box method. I think a lot of you would appreciate that right now, especially since that leading coefficient is 2x squared, and then plus 21, and then minus 17x. All right, let's see. I'll use a different color. Ooh, I haven't used orange yet. All right. So there's 2x and x. What two numbers multiply to 21? Well, that's 7 and 3. But wait a minute. There's got to be a negative 17 some. So maybe negative 7 and negative 3. Let's see. So I have negative 6x and negative 7x. Uh-oh. Those don't add to negative 17. So I'm just going to do a little switcheroo. I'm going to put the minus 3 here and the minus 7 there. So negative 14x and negative 3x. Yes, it does work now. So there's my 2x minus 3 and x minus 7. See, even teachers too need to do a little switching around when we're guessing and checking, and that means that you should too. All right, example number 4. Let's pull out the GCF. But wait, is there a GCF? No, there's not. Okay, so skeleton template up. All right, I'm going to try to do this one out without the box. Can I do this? Should I do this? Should I be brave? I don't know. X squared times x squared is x to the 4th power. And then 81. 9 times 9 is 81. But I think, yep, they got to both be negative, right? Because they have to add to negative 18. If you couldn't do that in your head, that's okay. You can use the box method to help you. But now, check it out. I'm looking at 2 of the same difference of 2 squares. So, oh my gosh. This guy's going to get 2. Or girl, this girl's going to get 2. We'll say one of them's a girl, one of them's a guy. Okay. So this polynomial will get 2 factors. This one will break down to 2 factors. So what are the 2 factors? X and x, 3 and 3. One of them is plus, the other one's minus. Copy paste. X and x, 3 and 3, because 3 times 3 is 9. One of them's plus, one of them is minus. We can write it like that. Or we can get super fancy and we could say x plus 3 squared and then x minus 3 squared. So we have 2 choices. That one was kind of cool, so I'll put a bubble around him. All right, that's a wrap, folks.